Unit 3B, calculating averages from a frequency distribution. Here's an example of 22 individual scores. To calculate the mode, we look for the most repeated score, the score with the highest frequency. Well, it's pretty clear that 1 is repeated the most, so 1 is the mode of this distribution. To calculate the median, we could take the number of scores, which is 22, divide that by 2 to get 11. And we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 from the top. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 from the bottom. Since we have an even number of scores, there is no score in the middle, but the median would be halfway between 1 and 2, or 1.5. To calculate the mean, we would have to take the sum of the scores and divide by the number of scores. Well, if we sum these scores together, we're going to get 66. And the mean is the sum of the scores divided by the number of scores, 66. And if we count the scores, there are 22 scores there, so the mean would be 3. There is a faster way to get the sum of the scores. For example, if we took all the 1s, and instead of adding 1 plus 1 plus 1 plus 1, etc., to get 11, we could use multiplication as a shorthand for repeated addition and say 1 times 11 to give 11. Similarly, we could take all the 2s, and instead of adding 2 plus 2 plus 2 and so on 9 times, we could say 2 times 9 is 18. Keep doing that pattern. 17 times 1 is 17. And finally, for the score of 20, multiply that by its frequency, 1, to get 20. Now we could sum 11, 18, 17, and 20. And if we do that, we're also going to get 66. Let's construct a frequency distribution table for these individual scores. The individual scores are 1, 2, 17, and 20. How many 1s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the frequency of 1 is 11. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 is repeated 9 times. So the frequency of 2 is 9. We have 117 and 120. That would be a frequency distribution chart for these data. In our table, we could sum the frequency column and get 11, 20, 21, 22, 22, and we would notice that the sum, sigma, of the frequency column is equal to the sample size, 22. If you sum the x column, you're going to get 40, but that is not a meaningful number. So we do not sum the X column in a frequency distribution chart. I'm going to extend the frequency distribution table to have a third column, which would be X times F, or XF. When you write symbols next to each other, algebraically, multiplication is understood. X is 1, F is 11. 1 times 11 would be 11. 2 times 9, 18. 17 times 1, 17. And 20 times 1 is 20. We do not sum the X column in a frequency distribution table. We can sum the frequency column and get 22. Remember, the sum of the frequency column gives you the sample size. And finally, we could sum the XF column, and we're going to get 66. So this is the sum of the XF column. And we can use this chart to calculate the mean of this frequency distribution. So this is the table we just filled in, and we're going to use this table to get the sample mean for this frequency distribution. And we're going to use the XF column as a way of getting the sum of the scores. If you recall, the definition of the sample mean was the sum of the scores divided by the sample size. Well, instead of summing the scores individually, we could multiply the score by the frequency and sum those. And that's going to be our formula for the mean of a frequency distribution. Because n is equal to the sum of the frequencies, sometimes the formula is written this way, and sometimes equivalently it can be written that way. In any case, the sum of the XFs in the numerator would be 66, and the sum of the frequencies, or the sample size, would be 22. So therefore, the mean of this frequency distribution would be 3. From the frequency distribution table, we could also calculate the other two averages, mode and median. To determine the mode, look in the frequency column for the highest frequency. The highest frequency is 11. That means the corresponding score, 1, is repeated 11 times. So 1 is the most frequent score, so 1 would be the mode. To determine the median, we would take the number of scores and cut it in half. The number of scores was 22. Divided by 2 is 11. And what we would do is count from the top 11 scores. We happen to have an 11 right here. And from the bottom, 1 and 1 is 2, and 9 is 11 also. So we have 11 from the bottom. And the score in between would be the median. But when you have an even number of scores, 22, there is no score in the middle, so we take the mean of 1 and 2, or we go halfway between 1 and 2, 1.5. You could also say the mean of 1 and 2, add them together and divide by 2. That's 3/2, or 1.5. You could also use the calculator to find averages. Using the TI-84, first step is to clear the lists, which is second memory number 4. Enter. Calculator should say done. Then go press Stat, Edit, and enter into L1 the scores, the X's. And enter into L2 the frequencies. Now press Stat, Calculate, choose the first option in the menu, one variable statistics, press Enter. Then depending on your calculator, you'll either have a menu like this, or you'll have to put in L1, comma, L2 to indicate to the machine that you want to consider 2 columns, L1 and L2, not just L1, which is the default column. If you have a more modern calculator, it will give you a menu and you'll fill in L1 for the list, that's the X's, and you'll fill in L2 for the frequency list, that's the frequencies. Navigate down to Calculate, press Enter, and you'll have the mean, X bar, the sample mean, would be indicated as 3, and if you scroll down, you'll see the median also listed as 1.5. This calculator does not show you the mode. That's the end of Unit 3B. See Unit 3C for a discussion of weighted means.